Hey, happy Tuesday, everybody. Hope you're doing well. Got a couple things today. I don't need that one there. We're going to talk some of Chapter 8. We're not going to get through all of it. So my thought here is we just skip the quiz on Chapter 8, if that's okay with you folks. Still do read at least the first bit of the portion that we're going to cover. We don't need to get into some more advanced topics. If you're continuing on in software engineering, the 2151 course, Object-Oriented Programming in Java, we'll finish out and actually dive deep into the rest of those inheritance topics. We just need to know enough so that when we start using it, when we do our Java FX stuff, it doesn't look crazy. And then, a little bit of it will make some sense because we got some basics there. So talk the basics of inheritance, do more examples with classes, do more examples with testing, because that's what you're going to need for project number 3. And then next week, we'll pick up all the Arrays chapter, just a little bit of that chapter 12 next week. And then we've got the midterm coming up as well. So tonight, I'm going to give you last semester's midterm for you to look at. I'm not going to give you the answers today, but you can look at the format here, and we'll look at this is what the midterm's going to look like. And then next week, we can go over the answers to it if you have questions, thoughts, or concerns about it. Does that make sense? Cool. So if we don't have really a quiz on Chapter 8, because we're only taking the first, third of it, essentially, I won't have any questions about it there, like the quiz-style questions on the midterm. So the midterm's half quiz-style questions and half, please code something. Generally relatively small, not a large thing, definitely not size of a project or anything. Something you can get done in a sitting is the idea here. That's sort of the goal. So we'll talk more about classes, more about testing, more about inheritance, talk about the midterm. Yeah.
Yeah. I was wondering, are we going to have a week with the midterm?
Yeah. There's nothing else going on in that midterm day. So, it's gonna, I don't know. I don't really like the time limits on it. So we might not even have a time limit. It might just be open all week like a quiz is, because that just makes life easier for people. I know, sitting down and saying, okay, I have 4 hours to do this thing, it's a big chunk of my grade, is relatively obnoxious. And honestly, it doesn't really measure if you can do the things that you've learned. So we'll go with no time limit on it. So it'll just open up on 10/26, and then you'll have until 11/2 to turn it in. But I do want it in before class starts on 11/2, so we can go over the answers to it. So like the quizzes, I've got till 11:59 p.m. tonight. This one will be due by 6 p.m. the start of class, so at least I can go over the answers to it. That way it gets done and out of the way, okay? And then on 11/2, we'll pick up our last individual project. So if things didn't go so great on some of the earlier projects, don't stress too much about it, right? Like project 3 was worth more points than project 2. Project 4 will be worth a couple more points as well, because we don't get to forget about anything. Right? All of these tools, all these techniques that we're learning, we keep applying to the next project and the next project, the next project. It just keeps building on itself. So this will be worth probably 20 points or so out of that project's category, and that will cap off the entire project's category, if that makes sense. And that one itself makes up, 35%? Let me double check. Yeah, 35% of the overall score, right? So if we look at, it's here, right? Let me find the right page. That one's not it. I think it's the grades page. Give me just 1 second. I want to make sure I don't screw this up. I think this will show me the right thing. Okay, good. Yep. Put this back here. So here you'll see, right, the projects and the current weight towards that category. Once we add project 4, 14 points, sorry, 14 points. Once we add project 4, then that'll be the final weights for all of it. So it'll be 3 plus 8 plus 11 plus 14 plus 20 will be the total project score. So your score out of that will make up the 35% of your actual final score. So that one will be locked in once that project's done. Does that make sense? Sometimes the category system or the weighting system messes people up a little bit, but I find it easier. But maybe I'm just crazy. All right. Cool. Oh, and Maddie on Twitch here. You ready for a dad joke? You got it. I got a couple more good ones this week. Where'd that one go? Yeah, so I've been thinking, civilization, we've come a long way. A little more than 100 years ago, right? We had our very first flight in 1903 or so, and so many years later, right, we were able to land on the moon. and so many years later, hopefully we're going to be making it to Mars. But of all the inventions in the last 120 years or so, I really think the dry erase board is the most remarkable. All right, so let me fire up NetBeans here. Maybe it'll fire. I should have started this sooner. 10 out of 10. All right, I'm glad that was a good one, Maddie. Other inventions really high up on that list. The shovel was really groundbreaking.
The jackhammer is also groundbreaking.
Yeah. Yeah, other groundbreaking inventions include the jackhammer. Those are the projects. All right, they found the flip-flops. My son's shoes. Over the pandemic, he's grown a bunch. He just turned 14, and we didn't really go a whole lot of places, so we didn't need a whole lot of shoes. So thankfully, we saved some money there. He's just worn the same pair of flip-flops forever, but now his feet are bigger than mine. Now, if we're going to start going back places, he needs like actual shoes again, and then nice shoes for things. And shoes are a racket, man. I don't know why they're so expensive. All right, so new project here. So this is Java application. We should put this in our 1500 folder. Call this inheritance. I'm just going to mark this one as the evening as well too. So keep those straight. Most of the time I do the same examples for you folks in the morning class. Sometimes we get into slightly different things, just depending on what's going on, what's at the top of my head. All right. So to start off, again, we're not going to put anything in the main method yet. Right? Nothing needs to go in here at the moment. So when we work with classes, we're writing class code. So we're putting a new Java file out there. This is the blueprint for how this noun behaves. All of its attributes, and these are all the things that it knows about itself, and all the methods, the ways that we interact with it, all the things it knows how to do. So if we go make a new class here, let's call this one, how about we can go, the book follows this kind of example, but I think it's pretty nice here. We'll call this how about a product? And then a product is something that we're going to sell. Right? Imagine we like to sell things. We're into the market, and we want to sell a bunch of products. So things about a product, then, that if you're going to sell it, you need to know. And what sort of things do you need to know to sell something? A price? Sure. So remember, all of our attributes here are going to be private, to say only the class here has access to it. So it's a private attribute, and then price is probably a double, right? You probably care about your pennies. Maybe an integer value if you want to, but that's fine. So private double price. Sure. What else does a product know about itself, or can we say about a product? What other kind of attributes might it have? Yeah, the name, sure. So that's probably a string value, right? The name of the product. Sure, so I can say, okay, I want to sell you this cheeseburger for $1.50. I'm hungry, so we're going to be selling a lot of food today. It's a bummer the Arby's right down the street closes at 9. So I don't have an Arby's out by me, so. Anything else a product might know about itself? Size? Yeah, you can have a size. Like probably as a string. Look for the size of it, sure. Anything else? Like, are we making these things ourselves, or are we going to buy something from someone else and then sell it? Like, be just a reseller. What do you think? It can be up to you. You can do either way. Should be, so we can buy it from someone else. So we're going to buy it wholesale, and then we'll sell it markup. It'll be like a grocery store. Sure, we can do that. So that's probably then we need to know like the cost, right? Our cost here. So maybe this should be like the sales price, and the cost is how much it cost us. Does that make sense? We can track those things. Sure, we can do that. Okay, that's probably pretty good. And if we come up with other attributes, we can go add them later. So again, always start with your attribute list. Right? When we're thinking of, hey, how am I going to track when I'm selling all these products? You know, the things that I need to know about the products. Great, but let's start with our attributes. Then we can get all the methods. Now again, NetBeans gives us the shortcut. So we don't have to type all the methods out by hand. But again, you know, there's nothing wrong with doing it by hand. It just is a little longer. So for methods, we are going to write public methods that we want people to interact with. Typically, all of our attributes need a get method so someone can actually get what the value is. Right? If we don't expose a get method, if there is no public get method, that attribute is only usable inside the class. So if someone says, hey, I want to build a list of products that I'm going to sell in my catalog, they can't get at this particular attribute. Right? Whoever's using the class. You can get it inside the class, but whoever's using it to make that list their catalog they're going to ship out. You folks never got like the Sears catalog sent to your house, did you? That's not a thing? No, I don't even remember it either. I just remember people talking about it. I do remember the Target catalog though. My kids love that. Target will send like around Christmas time a list of all their things out. They love flipping through it. All right, so we're going to let NetBeans write the code for us. So, or if we wanted to do our own, we could say, hey, a public method, because we want someone to be able to use this, and then what type is it going to return? Is it going to return something or be a void method? Generally, our get methods, right, if we're going to return something, we would have this type of double, right, and it'd say get sales price. No arguments, right? If you can just get the sales price with no arguments, and all it does is it returns the sales price. Sales price. Okay, so get methods are really boring to write. So that's why we like the tool to do it for us. So forget that one now. You right click and go to insert code and you say getter. And you just check the box and say, yeah, I want all of them, and it generates them for you. Now I have all my get methods. Right? You can do it by hand if you like typing. Go for it. There's nothing wrong with it, but I'm lazy. So I'm not going to. Now, things about our products that are changeable, we should have set methods for, or some way of interacting with it and changing it. Now, the name of an item probably is not going to change, right? The size of the item is probably not going to change, but our sales price is probably going to change, right? If we want to put our item on sale, which is, I mean, everything's on sale, but like sell it at lower than the usual price is what we typically mean when we say something's on sale, which is really funny wording. English is hard. We might change the sales price. So we probably need a way to interact with sales price, right? The cost of something is probably fixed, right? Once we buy the thing, we can't go back and say, oh, I actually paid less for it, right? We know how much we paid for it when we bought it. So the only attribute that we need to be able to change, I think, is set price. So when we go to insert code and we insert a setter, the only thing we need here is for our sales price. Right? The other ones don't really make sense in terms of the problem we're trying to solve, that these things should be changeable. So again, whether or not you can change an attribute just depends on the object, the particular noun we're trying to build a class for. Okay? Then we also need a way to give initial values then for these things. Right? If you can't set them with set methods, the only way you can set them is through a constructor. Remember, our constructor is that special method. It's public and the name of the class. That's the constructor method, is how do you create an instance of this object? And we're going to use that every time we make a new one of these. So we're going to insert a constructor. And then we say, okay, what arguments should the constructor take? Well, we should want all of the arguments for the constructor here. So if you give me the sales price, you give me the name, you give me a size, and you give me a cost, I'm going to set my this dot attributes, the instance attributes. So this current product, whatever we're acting on, will have its own sales price, its own name, its own size, its own cost. We'll set it to whatever arguments we were given. So it's up to whoever's using my class to make sure it gives me values. And again, we could do some sanity checking, right? That's probably a good thing to do. So for sales price, you probably aren't going to sell something for negative money or even zero, right? You're probably not going to give things away. For some reason, stores throw things out rather than give them away. I don't know why it happens like that. My mother-in-law used to work at Bath & Body Works, and they would actually have to destroy the products they were throwing away. Like, soap doesn't go bad, folks. They had to destroy the discs and things.
Yeah, because people were, because they were throwing them within the dumpster, and then people were dumpster diving, and they're like, holy crap, I just got like $500 worth of games.
Why were they throwing them out if they were $500 worth of games? I don't know.
They needed the shelf space.
That's depressing. No longer in season. Yeah, yep. You have to get rid of the seasonal stuff. So that stuff is depressing. But we're going to say you can't. Well, maybe we'll let people give stuff away. It's our code, right? So when we do our set sales price, if we want to make sure that our products are not selling at a negative value, right, which is a good thing, a product or a class should maintain its integrity, right? This idea where we've encapsulated all the details together. I have all my private attributes, and you only get at things through my public methods with this idea of abstraction. You don't need to know what I do behind the scenes. You just need to know my public methods, right? We don't know how scanner works, but you get to type in and it gives us strings back, right? We're working with it abstractly. So we can do that sort of sanity checking and maintain the integrity of our object. So we can say, hey, if the sales price is less than 0, so I guess we'll say 0 is allowed, then we'll just set this sales price to 0. Again, there's better things to do here, but we haven't gotten to them yet. Don't worry about it. So we'll say, okay, if you give me negative, at least we're just going to stop it at 0, right? So I'm not going to give them money for buying a product, okay? That's a whole multi-level marketing scheme. But we're not doing that for our products, right? That stuff is crazy, by the way. Like I don't get it. I don't.
7 cycles they run out of people.
Yeah. You can only sell to so many friends, and then you run out of friends. Which then you have to move on to recruiting your friends to sell to their friends, and then you're like.
After 7 cycles, they run out of people on Earth.
I mean,
like completely.
You can always buy more bags.
They all are part of that multi-level scheme anyway, so we can't sell to each other anymore.
Hey, come to my sales party. Oh, I was having a sales party.
But it's the same stuff.
But I like the stuff. I like the stuff. I don't know, the one, it's, I don't know how multi-level it actually is. Like, it's Usborne Books. They've got really cool books. And I love books. I'm a giant nerd, and they've got really cool, like, illustrative science books and things, and my kids love them. So I'm a sucker for that. But, you know, you can always buy more books, right? Yeah, they got some really good ones. So anyway, so we're going to do our sanity checking right inside of here to maintain the integrity of our object. For cost, right? It's sure we're getting it here. We probably didn't get paid to have these items again, so we could do some sort of sanity checking here if we wanted to. So we don't have a set cost method, but we can do it right in here too. We can say if the cost is less than 0, the cost equals 0. Else, say our cost equals the cost we were given. I'm doing the format, the source format, Alt-Shift-F all the time, by the way. It automatically aligns all your curly braces and things. Like, it's just a habit as I'm typing. So if you see things move around without me doing that, that's the format, right? It's super handy. So you can get really ugly lines, like, it doesn't matter what you did here, and you give it a format, and it fixes it for you. It's beautiful. Okay. So sure, we'll do that sanity check. And then if we have our code down here doing the sanity check, we don't want to repeat it up here. If you have the same code twice, you should feel bad about yourself. So all we need to do is call set sales price. We'll say set sales price given the sales price, right? One method can call another method. So our constructor method can call our other method. Okay? Gives us a warning. We'll talk a little bit about that once we continue on in inheritance, but we're not quite there yet. So then other things product can do. Right? So far, it's really boring. It just has a bunch of attributes, has a bunch of get methods. But things it can do for us, like we could calculate our profit. Right? If we know what the cost of it is and we know how much we sold it for, we can calculate how much money we're making off of each product. Right? So we can add a method here, like public double get profit. Right? So our profit then, so our double for profit is going to be the sales price minus our cost. Right? If I sell it for $1.50 and it cost me $1, I've made 50 cents. And then we can return that profit. Not anything groundbreaking or like amazing, but this having a method here saves me from having to do that calculation elsewhere. So over here in my main method, if I actually want to make some products here, I can go use that method every time and it will calculate it for me. Like the class knows how to do the things that the class is responsible for. Okay, so we can ask some people if we want to make a bunch of products. Right, or we can sell a bunch of products. Sure. So we'll make a scanner. Keyboard equals a new scanner. Given system.in. Great. And then, oh yeah, we got to do our import. And then we'll have a string for the name is keyboard.next line. Oh, we should probably ask them to enter a name, right? So enter name of the product you are selling to me. Sure, and I'm going to do a couple of these here. enter the size of the product you're selling to me. We'll have a string for size. Enter the cost of the product you're selling, and then that'll be a double for cost. And that needs to be double.parseDouble, right? Convert it to a double. Parse double, give it the keyboard next line, and enter the sales price, I guess. Sales price of the product you're selling. We'll have a double for sales price. Given double.parseDouble. So the code that has the main method is responsible for user input and output. Right? This is the one, because I know it's in the main method, that they're going to be typing at the console here. Right? The class itself should have nothing to do with using scanner to get keyboard input. This idea that our classes are reusable and portable, and we can, our code is so wonderful, we're going to use it in a mobile application, we're going to use it in a web application, we're going to use it in a graphical user interface application because we just love this product class. It's a bit of a stretch, but that's the goal. So the class itself should be independent of any sort of user input. So the way that it gets values is by the methods. We have a method that takes an argument here. So if I wanted to write a mobile application, it would still use the class and it would get values differently. And there's no like console on your phone. At least I don't think there is. Probably is somewhere in Android. I don't know about iOS. But they're going to just give the values from the other way that we interact with the user. So the class itself just accepts values through the methods. So we're going to go get a bunch of values, and then we can actually make an object. Right, so this is creating an instance of the object. So we're going to say product, my product or something, equals a new product, and we're going to give it all the arguments that we need to give it here. So right now, it says constructor product and class product cannot be applied to the given types. Required double, string, string, double, found no arguments. We didn't give it anything, so we need to give it the double. I don't even know what order this was in here. So the sales price, sure, so we give it the sales price. Sorry, I should make my phone be quiet here. There we go. Now it'll just buzz and you can hear the buzzing. So sales price, and then the name, and then the size, and then the cost. I think was our order. Sales price, name, size, and cost. So the variable names here don't need to match, right? Inside the method, I'm going to call whatever you gave me sales price. Right? You could call your sales price S. It's a terrible variable name, but when you pass an argument to a method, it could care less what you're calling it. It's saying, hey, when I get a double from you, I'm going to call it sales price. Right? So just because the names match, like that's just to make more sense of it to me, that this is the sales price. Right? And when we hand it to our product, it is a sales price. Sure. So make our product, and then I can tell them, hey, you will make, and then append in here my product dot get profit. If I buy this. Sure. So let's try it. So see if it does what we expect it to do here. Right? This is the by hand human testing. We're going to put it in main, give it some values, and see. Well, if I say it cost me $1.50 and I sell it for $2, I should make 50 cents. Right? It's the same thing we're going to do with unit testing, but we're just going to eyeball it here. So what are we going to sell? We're going to sell books. What size? These are large books. The cost was $1.50. We're going to sell it for $2. Oh, goodness. Hang on. I think this compile and save thing bit me again. It's never helpful. Never helpful. Try that again. All right, books, large books, $1.50. We'll sell it for $2. So you make 50 cents if I buy it. Okay, it seems to be doing what we expect it to do, right? And again, we could try all the get values, make sure the things we gave it, we get back out, right? You could even do funny things inside of the code that has the main method here. We could write other methods, right? So I can have a public void, public static void. We'll say print product. Now the funny thing here is you can give it, right? The only thing we've done so far is like strings and ints and doubles for arguments. You can give it a product. We'll just call it product. If you give me an instance of product, I can go use that instance of product to do anything with its methods. So you could say the product name is product.getName. And I'm just going to repeat a bunch of these. So we get name, we get size, we get cost, and we get price. So get size, cost is get cost, and sales price is get sales price. Right? So if you give a method an object, an instance of an object, it can go and use all the methods here. Right? The cool thing, what happens behind the scenes, I think Word works better than my whiteboard. Although I did like the whiteboard, but I think it was slowing things down. So when you tell Java, hey, I want to go make a new product, right? You say new product, and you give it a bunch of values. Right? It says, okay, somewhere out in memory here, x3792, right? Let's go make a product here. What it stores in memory then, now, is a string value. A string value is the memory address of where that string is in memory. It doesn't put the string at 3792. It says, okay, sure, this string, let's put it out at x239f, right? And that was book. So what it stores for name is x239f, right? It's just pointing over here. It's an address. Sorry, I can make that higher. Stores the address. Then for a double, though, our cost, it's actually going to store the cost right in here. So we can put the cost, right? It takes, what do we say? Is that 8 bits? 8 bytes of memory for a double, and it will store that $1.50 right in here, right in this location. And it will store the size is another thing. So we said large, right? Gets put somewhere out in memory, say 72BA or B9. I don't know. So size will point to that memory address, and we'll store 7239. And then the sales price is going to store right in here. So each memory address with a 64-bit system takes up 8 bytes. Right? 8 bytes is 64 bits. So we can address our memory with that. So 8 bytes for the size, plus where it actually is stored in memory. 8 bytes for our double, which is a cost. 8 more bytes for the size, which points to another location in memory. And then 8 more bytes for this double here. So for every product I make in memory, I'm using 8 plus 8 plus 8 plus 8, plus whatever the size of these strings are. I have no idea. Right? We'd have to go look that up. But so every time you make a new instance, it's allocating new space in memory to store all of the attributes. So every instance attribute gets stored every time you make a new one of these objects. So every new product, if I sell 5 different products, I'll have 5 different sets of these here out in memory. And each one is in a different location, like 92FB or something. Right, that's what's happening behind the scenes. So if I go to pass it to a method here, what I give it here is I say, hey, method, take a reference to this object. So what I hand is x92FB. Right? When you pass things, when we're passing things by value, the value of that product variable is the memory address. It says this is where the product is in memory. And that's what we're passing. Right? When we pass integers, and we pass doubles, and we pass floats and chars and the primitive types, when we pass by value, they're getting a copy of that. Because here's the actual value. Right? We're not passing a memory address, we're passing the actual value that's being stored. When you deal with objects and classes, if you're passing that instance, the value of that variable is the memory address here. So then inside this code, I can say, oh, hey, at the memory address, here's an instance of product, call a method, do the thing you're supposed to do. So what that means is inside of this code, if I wanted to, I can call set methods. I can interact with it. I can do methods that will change the properties of that, or change the attributes of that object. So if we wanted to in here, just for fun, we could like say, hey, we're going to put this object on sale. Here, let's do that in a different method, actually. Let's do that. Let's say public static void. Remember, these are static because main is static. I don't have an instance of inheritance evening that I'm saying new inheritance evening. I'm going to call it whatever, and then dot methods. And static methods just exist at the class level. So there's main at the class level, there's print product at the class level. Nowhere do I make an instance of this class here. I'm making instances of the product class, and I'm using their instance methods and instance variables and attributes. Right, this is the difference between static and instance variables. So let's do static void discount product, given a product. And how about a double for the percentage, maybe? Percentage discount. So if you want to put something on sale, sorry, is that too small? I can increase the font too. Okay, sorry.
Not your fault.
So if we want to put a product on sale, right, we can get the current price. So we'll have a double for current price. Can be the product dot get sales price. Okay, and then the double for a sales, discount price is going to be the current price times, now the percentage discount. If you ask someone for a percentage discount and you say 10%, what they mean is it's 10% off the original price. So our arithmetic here has to be a little bit funny. So it's probably 1 minus the percentage discount, right? So if they say 10%, we want 1 minus 10%, 0.1, which would be 0.9. So it's 90% of the original, right? That's just our arithmetic here. So now we have the discount price, and then I can say product dot set sales price given the discount price. Okay. Now this is 3 different lines. If you want to do it all on one line and be fancy, you can too. You can say set sales price. No, that was not helpful. Set sales price given the product dot get sales price times 1 minus the discount. Right? If you want to do it all at once, you can. Like, you don't have to have separate lines here. Right? Totally up to you. Some people prefer this sort of thing here. If it's just some quick arithmetic, they'll just do it in line, essentially, here, without more variables. I like variables because in debug mode, I can see what it was set to. Right? If you're running in debug mode and you just have a single line here, you don't get to see all that arithmetic happen. If you have a line where that arithmetic happens, you can see the value as you step through it. So I'm partial to using variables. It makes it easier for me to debug code, but lots of people like this, and sure, not too big of a deal, but either one will do the same thing, right? So same as above, but less lines, yay. Sure. Just one other aside note, as you talk about software engineering, if you go on and take a software engineering course, there's all sorts of ways you can measure productivity of developers. One of the worst ones you can measure is how many lines of code they write. Weirdly, some people still like and think that's something worth measuring. If you're measuring how many lines of code I write in a day, if I write 3 lines like this or 1 line like this, which way do you think I'm going to write the code, if that's what you're measuring and basing my bonus off of? Yeah, I'm going to make everything take up lots of lines of code because it'll look good. Which is like the things that you measure, you get some weird results on. So just, there is some value in measuring that, but it's not, hey, they've got 50 times the lines of code as someone else, they must be 50 times better.
So it's like an English class where you make a paragraph one.
Yes, your English papers, you can pad your paper.
My paragraph contains many of them.
Yeah. Well, papers are fun. Like, you have to tell them what you're going to tell them, you have to tell them, and then you have to tell them what you told them. Like, okay, sure. One fun thing I learned, like doing academic research and things with research papers, like actually things like published in journals and whatnot, is you want to read like the introduction, and then you skip to the end, the conclusion, and if those were interesting enough, then you go to the body.
Yeah.
So like, it actually is important to have a good introduction and a good conclusion, because that's what a lot of people are going to look at first. Yeah. So it's a thing. All right, so we can discount our products then, right? So we'll do the same sort of thing, and then we can call our print product method given my product, and then we will call the discount product given my product. And what sort of discount do we want to get? Like 0.1, we'll give a 10% discount, and then we'll print the product again, right? To make sure that it changed. Again, this is all by hand, saying if this thing happened, it should look like this when it comes out. Right, so we'll give it a run. Let's sell a cheeseburger. Let's sell that. The size, that's a small cheeseburger. It's the cost probably, 75 cents to make or so. I'm going to sell it for $1.29. So initially, cheeseburger small, $1.29. And then when we get that 10% discount, now it's $1.16. Cool, so it seems to be working, right? It's doing the thing we asked it to do. And we can use our fun little methods here that act on products. Now, the same sort of like discount product, if that's something we're going to do a lot, we could make that a method in product if we wanted to apply a given discount. We could do that sort of thing. And maybe that might make sense as a quick little way to change. The problem with that is you're going to lose the original price. Right? Maybe at some point we need to store original sales price and like discounted sales price, and then we could, right? We can come up with all sorts of different ways that product can be useful for us here. All right, so we did that by hand. Now let's make sure we can make the computer test it for us. A little bit redundant at this point, but ideally we make the computer test it, and we don't have to do these funny main methods with all this stuff in it here, right? Because this is not actually useful for like selling someone products. So I'm going to go to the class, I'm going to right click, and I'm going to say navigate, go to test. It's going to generate a bunch of stuff. Make sure you have JUnit 4 picked, right? JUnit 4 is what we need to work with the Ant projects. Leave all the other stuff checked here, nothing checked on the right-hand side. You're good to go. We'll make a new file over in our test packages section over here. And now again, all of the gets are really boring. I'm not going to test gets individually, so I'm going to pull all those out. Oh, there's the set sales price. So all the gets are boring. I'm going to get rid of them here. I'm going to test my set sales price, and then I'm also going to test the constructor. It's like the constructor is taking all my attributes, setting a bunch of values here, and to test if the value got set, I have to call the get method. So like trying to just test a get method by itself is redundant. So I'm going to add a app test, public void test constructor. Okay, and then we give it three things, right? We're going to arrange, we're going to act, and we're going to assert. So all the variables we need to lay out what we're about to test. I'm going to have a string for the expected name is, we'll say book. We'll go back to books, I guess. We'll have a string for the expected size. We wanted to sell some large books here. It could be like encyclopedia salesman. A double for an expected cost, probably $1.50, and a double for an expected sales price. We'll say it was like $2.75. I don't know. Come up with some values. Then act. So act is where we're calling the code that we're testing. Right now we want to test the constructor. So we're going to call the constructor. So we'll make a product, my product equals a new product. Oh, you just do lowercase p product. Sure. So the new product given. Now we needed the sales price. Then we needed the name. We needed the size. And then we needed the cost. We give it all the variables here. Now we need to see what does it actually think it is when I call the get methods. So then I'll have a string for the actual name is my product.getName. Right? Call the get methods and make sure we get back out what we expected to give it. It's possible to screw these up. Like it's difficult when you make it generate the code for you. Like if you ask for a name, it's going to give you the name. When you're doing these things by hand, if you're not using the tool, sometimes you put the wrong thing in here. And like when you, instead of returning name, you'd return size. Stuff like that can happen. So this is our sanity check. Hey, is this going to work here if I give it a bunch of values? Then a string for the the actual size, product.get size, a double for the actual cost, product.get cost, and a double for the actual sales price, product.get sales price. Okay, we're going to get all the values out. The other thing we could do in here is if product had some sort of default values that we're not passing in the constructor, right? If we're setting something else, so like with your plane, you guys are doing plane, so right, its current altitude should always be 0. There is no way to give it, hey, when you make a new plane, put it at 50,000 feet. We just don't do that. What?
What if you build it at that?
You've broken the laws of physics. So if the constructor is setting a default value, then we can test, did that default value actually get set? So not only can we test the things we gave it, but we can also say, hey, what was the default? Did it start off at 0, or was the landing gear enabled set to true, that sort of thing. So we could add additional gets for anything that was a default value, right? Not just the things we pass, but hey, when I make a new one, did it set it here? Right, and then we assert all these things are equal. So assert equal, let's just go down the line. So expected name, so expected on the left, actual on the right. All right, then an expected size, and the actual size. Expected cost, and the actual cost. Expected sales price, and the actual sales price. Oops, there we go. And remember, when you're dealing with doubles, because Java sucks at arithmetic, you need to give it a delta. How close is close enough for these two doubles here? Right, so like 0.00001, sure. As long as they're within some distance here. What is that, a millionth, I think? Tenth, hundredths, thousandths, 100,000ths? Yeah, That's as long as they're within 1/1,000,000th of each other, I'll call it close enough. I'm not going to worry about a millionth of a penny. Okay. And we'll see if they match. So let's test our file. I'm sorry?
Set that phone number to each other.
Yep, and it passes. So it'll pass if it doesn't fail. So we see 2 passed. We don't actually have anything to test sales price. So just be careful. Just because it says it passes doesn't mean you actually did anything, right? But yes, so we got back at what we expected. That was a good test for constructor. And then a test for sales price. Let's arrange. We'll act, and we'll assert. Okay. What we need to arrange then, we need a product and a price. So when I create a product, so I'm going to put the product constructor here in this arrange section, right? So I'm going to have a double for the expected sales price, and let's make that, I don't know, $1.25. And I'm going to make a product. There's a new product. Now this time I don't care what the values are, right? It doesn't matter what the values are here, because the only thing I care about is, does it do something when I call set sales price? So I can give it 0, an empty string for name, an empty string for size, 0 for the cost. The values don't matter. So I'm just going to give it garbage, and then when I act, I'm going to call product.setPrice. Set sales price given the expected sales price. So the only thing I'm testing here is, does this one method work here? Right? So the other arguments are irrelevant. If you give it values, great, but we don't need to check, we don't need to test them, right? We don't need to have expected values for them because we don't care. And I'll have a double for actual sales price. Product.get sales price. And then we can assert those ones match. I can just copy from up here. This is the nice thing. If you use the right variable names, right, like most of your asserts, you can copy paste. So you don't have to type it all by hand. Again, I'm quite fond of copy pasting things. So if I make a product and the sales price is 0, and then I set it to $1.25, is it $1.25? Let's try it. So let's test our file. All right, it passes. Life is good. You okay so far? All right, so that was a review then of things we've talked about before with classes. I've got 50 minutes in. Do you want to take a break now before we start new stuff, or start some new stuff and then take a break? I'm open to either. New stuff. All right. Yeah, usually whoever votes first gets to win, unless a bunch of people object. All right, so now that we have product, right? Now let's say, by the way, the state of Michigan wants their cut. We need to charge sales tax. But by the way, not everything gets charged sales tax because of our interesting tax laws. Well, I have 2 options. One, I could change product to make it do the things I need it to do. Or 2, I could not reinvent the wheel, right? And start with product and add more functionality. And that's what we want to do, right? We want to do the easy thing. So what we can do is I'm going to make a new class here. We'll call this a taxable product. And we get a new keyword here. We get this keyword called extends. Extends says we're going to create a relationship between this class and another class. So if we extends product, we've essentially said I am a product. I'm a type of product, but I'm a special version of product. When you extend a class through inheritance, you do all of the things the parent class does. So this is known as the parent class, or the superclass, or the base class. I don't know why we have so many terms for it. So whatever you're extending is your parent, your superclass, your base class. Whatever you are is the child class, the subclass, or the derived class. Right? Parent and child, super and sub, or base and derived. Sure, all sorts of funny names for things. Go for it. I'm fond of superclass and subclass, because I'll show you there's a keyword super that we use later on. So I'll try and use superclass and subclass, but sometimes I like parent and child. The base and derived are just too much of a mouthful. So right off the bat now, we are a product. We do all the things product does. So without anything else here, I can come back to my main method, and I can say, hey, I want a taxable product. Taxable product is a new taxable product. It's not going to crash yet. It will in a minute here. Don't worry. So we now have an object, and then with my taxable product, if I say dot, you're going to see, now nothing's bolded now, but we see all of the things here, like set sales price. We see get profit, get sales price, get cost, get name. all of those things, they'll tell you they come from the product class. So like the get class, you'll see comes from Java language object. ToString comes from Java language object. But all of the methods, all of the public methods that were available in product are available in taxable product, because we are is a type of product. We've created this relationship that says, I am one of you. I'm just going to add some more functionality. I'm going to do a special thing of you, right? And inheritance, we borrow from like our classification system. Remember, like back in biology, you have kingdom, phylum, class, order, family, genus, species, right? We're all a type of mammal, but then humans are different than other mammals, right? But we're all mammals. So all the things that mammals have in common, we all share. It's that's idea that this relationship between inheritance. You are a type of your parent class, but then you're special, right? So our taxable product has access to all of those public methods that product had, because it is one of those. And then what we do is we get to be special. Well, what makes us special? Well, we're going to have a double for tax rate here. So the tax rate is what's going to make the taxable product special. So when I calculate the sales price, right, I can add the tax to it automatically. So if I want to sell something for $1.50, I need to charge you 6% more. Thanks, Michigan. Right? So I'm going to have a tax rate. So I'm going to add a constructor here. And now this is where it gets a little funky. If your parent class here has a constructor that needs a bunch of arguments, if I try and make a taxable product here and I don't give it anything, is it going to know what the name, what the size, what the cost, and what the sales price are initially? No, it's not. So what we need to do then is we need, in our constructor for taxable product, we need to, public taxable product, right? That's our constructor method here. We need to get all of those values as well. We need a string for the name, we need a string for the size, we need a double for the cost, and we need a double for the sales price. In addition to that, we also want a double for the tax rate, right? So if I get all of those values, name, size, cost, sales price, what I'm going to do is I'm going to hand it to my super class, my product, and say, hey, product, here's all the values you need. So I can say super is the keyword, and I give it the values. Now, we're out of order here because I am messed up. So we need sales price first. Oh, look at that, name, size, cost. It worked. It did give me the right order. So super says, go to my super class, go to the class I extend, and run the constructor. Okay, given these values. So super says, okay, by the way, when you make one of me, go to product, do its constructor thing, and then come back to me. So super has to be the first line in your constructor. It's got to be the first thing you do. Part of that is because we rely on being one of those types of our parent class, that it has to exist first and have all of its attributes first. And then we can go and do our things. Right? We can load all of our attributes. And then we'll set our tax rate. So we'll probably have a method here for set tax rate, given the tax rate. Okay, so then we need a method for set tax rate. We need sets and gets. So let's go insert code. We want getter for tax rate. We want to insert code. And we want a setter for tax rate. But then set tax rate should do some sanity checking again, right? So we should make sure that if the tax rate is less than 0, we'll set tax rate to 0. Otherwise, we'll take your tax rate. Right? If you give me something that's not 0, this dot tax rate. Thank you. So it was orange before. Notice if they were both orange, I'm setting the argument, not my instance, the green one here. This tax rate. There we go. So great, so we can have a tax rate. Now we can calculate what we should be charging then. So great, we're doing set tax rate. Now, how do we get the price, right? Our product has a method for get sales price already. So what we want to do is we want to make a special version of this. We want to change the behavior of my parent class, because I don't want to get the base sales price out. I want to get the sales price plus the tax. So if we want to change our parent class's behavior, we get a really cool thing to do here. We say at override. At override this is just an annotation telling Java, hey, I want to change the behavior of my parent class. I want to do something different. So this is public double get sales price. Okay, And what it does with this annotation is it checks to make sure that you did the right thing. So if I typoed get sales price and I say get sale price, it's going to say it doesn't actually override a method from your parent class, from your super type. You typoed something. So it gives us a little bit of checking here to make sure that I have the right method name and the right arguments to make sure that I'm actually going to change the behavior. So if I want to get sales price now, I need to get the current sales price and then add my tax rate to it. Okay, so to get the current sales price, I don't have access to sales price. Right? There is no variable sales price that I have access to because product says that's private. I can't touch it, even though I am a type of product, I don't have access to it. So two things we can do. The easy one that we can do is there's a different level of access between private and public. Right? If I said public, anyone would be able to go and change it, which is bad because they can go set it to a negative value, and then they're taking money from me every time they buy my products. So we don't want to make the attribute public. What we can do is we can make it protected. Protected. So protected says that I have access to it, and any child classes of mine, any subclasses of mine have access to it. So it gives direct access to subclasses. So then in the subclass, I can actually now say sales price. And I can do something with it. I can change the value of sales price. Now this is great if we're writing our own classes. Sometimes you inherit from someone else's class, and you can't go do that. You don't have that option. So if that was not an option, right, well, I'll just comment this one out here. We can set directly if it's protected. Protected here. Marked as protected. Marked as, or declared. How about declared? That's a better. So if it's declared as protected, we can do that. The other thing we can do is I can get the sales price. So I can call get sales price. And then I can then go add the sales price times my tax rate. And we're going to, and we need to hand all of that to set. So we'll have a double for new sales price. Oh, no, that's fine. We'll just return. We can just say return. We get sales price plus the get sales price times the tax rate. Right? Or really like multiplied by 1 plus the tax rate. So if the tax rate is 0.06, 1 plus 0.06, 1.06 multiplied by our sales price, we're going to return that value. Now, this actually isn't going to work yet, and it's warning us here that it may recurse. It means it's going to call get sales price again, which will call get sales price again, which will call get sales price again. So I don't want my version of get sales price. I want my superclass's version of it. So I have to say super dot get sales price. So super dot sales price says, oh, go back to your parent class, do their thing, not the thing that you said you want to change. So this lets me run the product version of get sales price, which will actually give me access to sales price then. Then I can add my tax rate to it and return that value for sales price. So we have to do this if we don't have direct access via that attribute being called protected. So totally up to you. When you're building classes, you can make things protected if you want. But if you can also inherit from other people's classes if you want. So like if we wanted to, we could inherit from scanner. I don't know what we would actually do with it, but we could. And we could make our own version of it. Sure, there's some fun there. Okay, so then we can actually watch this happen. So if we go back to our version here, now this one lit up red, it's mad here, it needs a name. So what's a taxable product? Right? We charge taxes on hamburgers, right? You pay taxes at McDonald's, but you don't pay taxes on beef at Kroger, right? Prepared food gets taxed, but non-prepared food doesn't or something? Okay, I'm fuzzy on stuff like that. So we'll do a burger here. That's a small burger here, probably just like a McDouble or something. I can bring that up, sorry. Just holler at me if I need to zoom it up a little more. So it costs them probably like 97 cents or something, right? And then they're gonna charge me $1.50 for it. And then the tax rate then is 0.06. So I have to give it all the arguments here, which is a bit, right? That's a lot of different arguments here, but sure. We'll make that taxable product. And then I can say, let me print the total cost including taxes is, my taxable product got dot get sales price. Excuse me. Okay, and we should get 6% more than $1.50. Should be 9 cents more, right? So let's see if it works. Again, doing it by hand, we're doing a little sanity checking. We can go and actually write tests for it in a little bit here. The product size, a dollar, sure. All right, total cost including taxes, $1.59. That seemed to work. Okay, but now let's watch it in debug mode. This is where it's fun, right? So I'm going to put a breakpoint in here at line 50 and run it in debug mode instead. We can follow that chain of calls from here to here to here to here to here. It's really fun. Or at least I think it's fun. Maybe it's boring, but we're going to pretend like it's fun. It's probably waiting for me to type something in. Where'd my output go here? Output, inheritance. There we go. Enter the name of the product. Product 1, sure. Here we go. We got to our line. So now I can see all of my arguments here. I see I've got a product. I see I have my taxable product, right? I want to step into, because I want to go into this call here. Not print line. No, I don't want to step into print line. We go step over the expression. Is that it? And then into? Nope, that's print line. Step out of print line. Oh, come on. All right, that didn't work like I wanted. So let me just come back here. Taxable product. I'm going to put a breakpoint right in here. There we go. Then it'll stop for us at the right spot. Going into print, it's obnoxious sometimes because it's open source. And like it can actually, you can see what print line does behind the scenes. It's nonsense. All right, so we'll just step over. Okay, now we're in sales price. So in get sales price, we see this is our current taxable object. It has a tax rate of 0.06, and we see the inherited properties. So in debug mode, it's going to show you all of them. It's just showing them that they're inherited, like as a this is what you got from your parent class here. And then we step in again, and we're going to go back to get sales price of product. Now this is still the same object. This didn't change because we are a product. That's still the current instance here. We're just going to get back the sales price now that we have access to, $1.50. We do the arithmetic, right? Add that, and we get our total cost back out. You can also do that if you put a breakpoint at the constructor. We can watch it. It goes to the constructor, goes to the superclass. The superclass constructor runs. We come back. We do our constructor stuff. Life is good. We can do some fun stuff. So other things taxable products be able to probably do is tell me how much tax, right? Get tax. So we'll have a public double for get tax. I don't know, just get tax? Sure. So not the tax rate, but the like how much tax you're paying. Because when we do someone's receipt, usually we do like the regular price and then we include taxes later on, or so I don't know, it depends how you do your receipts. Yeah, does it last? They add it on at the end? Okay. So to get the tax then, right, we're going to return my super.getSalesPrice times the tax rate. Just the tax rate. Right? This is just the taxable amount we're adding, not the total sales price here. Right? So this is just how much tax it is. Now, because we have this already, right, we could then also do the arithmetic instead. We could just add the get tax. Right? If you wanted to not have to calculate it twice, it does the same thing. Either way is fine. This is probably more straightforward than having to call your other method to get the tax amount. Okay, so we can get, this is how much the tax is. Sure. Print stream. Here we go. This is what print line does. Sure. That was not exciting. Awesome. So we can also test taxable product. Right? There's not too much to test about it, right? We can set the tax rate, make sure the tax rate changes, and then make sure our get sales price gives us what we expect back. Right? We can do all that. So I'm going to right-click the class here and say navigate, go to test. JUnit 4, 3 checkboxes, good to go. And I'm going to get rid of most of the gets here because we don't want them. The set tax rate, yes, but then we're going to add a test for constructor, public void test constructor. Right, we're going to arrange spelled properly. We're going to act, we're going to assert. So to arrange, we need the name. Well, really, we don't actually need to test the rest of that it works. We could if we wanted to, but we've already tested product. So I know that the product stuff works. If we want to test that we made sure we did it in the right order, maybe that's a good thing to test, because if you put these out of order, when I go to get name, if I did name like instead of the size, they'd come up wrong. So maybe it's worth testing, right? To make sure we put them in the right order here. It's not too bad. So I'm going to go back to our product test first. I'm going to grab all this stuff here because it's essentially the exact same thing. Here, arrange, act, and assert, but then we're also going to add a tax rate. So we'll have a double for expected tax rate equals 0.06, and then our expected sales price is actually not 2.75, right? So I'm just going to call this sales price, because that's the sales price we're going to give it here in a minute. And then I'll come up with the expected sales price. Expected sales price with tax should be 2.75 times 1.06 or something, or 1 plus. We'll do this better. We'll use our variable. Sales price plus 1 times 1 plus, no, sales price times 1 plus. I can't get these right. The expected tax rate. Right, that'll be expected sales tax with price. Right, whatever the sales price was, plus the tax rate. Okay, so then instead of product, now it's a taxable product. Taxable product is a new taxable product. Now, taxable product wants different orders of things, right? We said you needed to give it the name, so we have the expected name. Expected name. We have the expected size. We have the cost. Expected cost. We have the expected sales price. Oh no, ours is just sales price then, right? Because that's going to change. And then we have the tax rate. So we get all those values. Let me bump that down a line. It's getting a little long here. And then we'll get what we actually got back out, right? Did they all work here? And then we also need a double for actual tax rate equals product.get tax rate. And then we can also get out then, right, the actual tax is product.get tax. Right? Well, the tax then should be our double expected tax. Should be the sales price times the expected tax rate. Right? So these are additional things. The tax didn't get set in the constructor, but we need to check it and make sure it's going to work here. Right? So our expected sales tax with price is the actual sales price. And then two more because they're doubles here for our actual tax rate, the actual tax, the expected tax, and then the expected tax rate. Okay, does the actual tax rate match the expected tax rate? And does the actual tax that was calculated match the actual tax that was calculated? And is the new sales price with tax what the actual sales price is? Okay, so we're checking a bunch of things here, just with testing did the constructor work. Right? We're testing all the gets at the same time. So let's test that one. And it passes. Right? Things look happy. I like that. So go back to test here. So to test the tax rate, again, we're going to do this exact same thing, essentially, but we're going to do a much smaller version of it. I don't care about everything except the tax rate here. So I'm going to create one of these in my arrange section because I need to use it for testing, and all I care about is the get tax rate. Right? So everything else can just come out. Let's give it a format. There we go. So the expected name, sure, empty. Expected size, empty string. Expected cost, we don't care, sure, zeros. Sales price, zeros. The tax rate, really, we can even give that a 0 because what we're testing is does the set work. So then I can call my product.set tax rate, given the expected tax rate. Did it set? So start it at something that's not the value. Make sure that set changes it to the value. Right? We don't want to start it in the constructor at this value, because that's not testing did it actually change with the set method. Okay, we'll give that a run. Oh, not debug, test. You can debug your tests too. You can put those in debug mode, which is fun. And do the same breakpoints and everything. All right, those ones pass. So we've tested our inherited class here, our subclass, our child class, our derived class, because we didn't want to reinvent the wheel. I didn't want to change product because product was so great. I used it in the mobile application already. I used it in my web application already. That code's there. If I change it, I have to change it everywhere else. So sometimes we get into like, hey, if I want to get a specialized version of it, I'm just going to make a subclass and I'm going to use that one. Makes life easier because if product changes, everyone who uses product has to change. right? Rather than, okay, I'm just going to change it for my particular use case here. So that's the basics of inheritance. We got a little bit more to talk about. Why don't we take a break? I got to go get some Coke. I'm not wired enough yet. And we can come back, wrap up inheritance, talk a little bit more about classes and testing, and then we'll talk about the midterm as well. I'll give you the midterm from last semester. That sound like a plan? So we should have time to get started on project 2, 3. I can't count anymore. Project 3. 3. If you want to sit, if you're not burned out and need to go home, we can sit and get working on that. If you have any questions about testing, because that one's due next week. Okay. Awesome. We'll put some more music on. We'll go on break. Ooh, Moonlight Boy. If you're still around, definitely not JavaScript for learning how to program. Python, Java, C#, a nice high-level language is much better for you. Alrighty. And we're back. Let's talk a little bit more about inheritance. A couple other pieces here that are interesting. So in our part with main here, where we're actually creating instances of these classes and doing stuff with them, here's a fun thing. Because taxable product is a product, if I wanted to call my print product method here, I can call print product and I can give it my taxable product. Because it is a type of product. It will treat it as if it were a product, getting the name, the size, the cost, the sales price. When I'm treating it as a product, I can't get the tax rate, right? Because it doesn't know about that. All it knows is that it has the attributes of product, the methods of product. But what's cool is the get sales price is going to run the correct version. And this is really neat. It's one of the fundamentals of object-oriented programming called polymorphism. It's a really fun term. You can treat objects of a child class as if they were their parent class. And when they run, when you do that, you'll get the correct version at runtime. So when this compiles right now, right, the compiled code has no idea that I'm going to give a taxable product instead of a product. Right? It says, okay, you are a product, sure, you fit. Right? You're a square peg, you fit in the square peg hole. No problem here. You're a product. But when it actually runs at runtime, when it goes to call get sales price, it says, oh, you're really a taxable product. Let me call the taxable product get sales price instead of the product get sales price. So let's give this a run. Whatever we're doing for that one, sure. And we get our burger, small burger, cost, and we get the actual sales price with the tax included. Right? Even though it called it, we were treating it as a product here. When it runs, it gives you the correct version. That's part of polymorphism. That's what it does. So we're treating our child class as the parent class, or our subclass as the superclass. But when we actually call for a method, if it's been overridden, we'll get the overrided version. We'll get the special version, which is super cool. So we can make a bunch of these things, and I don't have to change any of my other helper methods, right? I'm still just getting the correct price here, right off the bat. Okay, the other thing, if you make a class here that does not have a constructor, right? Or if you have a default constructor or a no argument constructor, we can do some fun stuff with that. So if we just had, I don't know, we can do, what do we want for a class with no arguments or no constructor? How about color? So then a color here, right? Remember, all of our colors are made up of red, green, and blue. And you get a certain amount of red, a certain amount of green, a certain amount of, at least for computers. In the real world, light works differently, but go take a physics class. I don't understand how that works. But we'll have a private int for red. We'll have a private int for green, and we'll have a private int for blue. And if you wanted to get fancy, you could use some of those other types, right, that store different values, right? If we're only going from 0 to 255, we don't need an entire integer that can go to 2 billion. We can use like a short that goes even smaller. A single byte won't fit it, right, because it goes from negative to positive, but right, if you wanted to, we don't care though. So red, green, and blue, and then I'm just going to write some simple, we'll make NetBeans do some simple code, not a logger, sorry. Insert code. So you got to be in the right location. You have to be inside your class when you go to insert code. If you do it up above, it's going to be upset with you. Insert code, we'll add getters, and we'll add setters. Insert code, setter. So you can change all of these, right? This is just how we want to represent a color. So they're all changeable here. And then maybe we want a constructor. So I have a constructor, but it doesn't need to set anything. Right? You can make a new one of these things, and I'll just set red to 0. We'll set green to 0. And then we'll set blue to 0. This is essentially the exact same default constructor that Java was giving us. Again, relying on defaults is generally a bad idea, though, because you'd rather be explicit about it and say, okay, these are my defaults here. So I'm getting black, right? If they're all zeros, I get black. If they're all on, I get white. Right? Again, opposite of how light works, but sure. That part of it is fun when I help do science for my kids. Light's just really neat. It's really neat. So anyway, so color is this. So we have a no argument or a default constructor. If I wanted to inherit from color, then and have, what is it? You can add the alpha value to make it like partially transparent. So with this like a transparent color, we can say I want to extend color. So it extends color here. And then we're going to add a private int for alpha. And we need gets and sets for alpha. So yeah, it's not the logger. My goodness. Nope. Oh. All right. Had a little bit too much Coke. Coca-Cola. A little too much Coca-Cola.
From like the 1800s.
I'm still technically a what is it? The term probationary faculty because I'm still new. After 3 years, I get the equivalent of tenure. So just wait for the dean to watch that part of the class. What are you telling your students? All right. So get alpha, set alpha, sure. And then we could add our same constructor if we wanted to. Insert a constructor. And sure, we don't need to take any alpha. We'll just set alpha to 0 here. What's going to happen if I don't call the superclass constructor is it's going to happen automatically. So if there is a no argument or a default constructor, it will implicitly get called before this runs, which is super cool. So if I go and put a breakpoint in color in the color constructor, I'm going to come back to wherever we have main here, and then I'll make a transparent color. So transparent color, color equals a new transparent color, right? And then we'll go color.set alpha. Sure, we'll say I don't know 155. Color.set red and blue and green. We'll put I don't know just some values here. Color.set red 25 and color.set green. We'll do 255 for that one. I don't know what color that actually is, but we'll have a bunch of methods here. Because it is a type of color, I have access to all the public methods of color. Right? With inheritance, we get that automatically. I didn't specialize anything. I didn't override anything. I didn't have to change any of those behaviors. All I did is add a new attribute here. Sure, that's fine. Right? I'm just saying, okay, I am one of these, but I also now track my transparency here, my alpha. So I'm going to put a breakpoint here at the transparent color. We're going to run this in debug mode. Right here, right? So some names, numbers. There we go. So now we're ready to go. So I'm going to step into here, and I go to my transparent color. I'm going to step. Now I'm in color. I'd never called the super constructor. I never said super. It happens automatically if there is a no argument constructor, which is cool. Like that, you want this to happen because you need these values to be set. You need this constructor to run before we can be one of those. Because if we don't have values, bad things can happen. Then I come back and I set my alpha here. Okay, so what is not going to work if I were to change color and say, hey, I need a int red, an int for green, and an int for blue. Red, green, blue, and these are all this dots. Right? If I go and set all my instance attributes, if I say, oh, I do have a constructor now, right? Transparent color, if it doesn't call it, and I go to run this, right? 1, 1, 1, 1, sure. Ooh, crash. No such method error. A void init not found. Init is another word for constructor. It's the initializer. We didn't explicitly call it. It crashes hard on us because there is no default constructor. If you write a constructor that takes parameters, you lose the default one. Okay, so we can't make an instance of a transparent color without calling the color constructor. Okay, so you just have to be careful. If you have a default constructor, great. Again, generally being explicit is better, right? And saying, hey, I want to explicitly call super. Where did I go here? Our transparent color, like call super. And we can just give it a bunch of zeros, right? If we don't care, this would be fine. This will not crash now because we're saying, hey, start off at black because I don't know what you want to go. We'll set them later here. But we can explicitly call it here and it'll work. So once we call the constructor, so it's not going to give us a compile time warning, which sucks. Like it really should. I don't know why it doesn't. I feel like it should be able to figure that out. But when we go to run and create the object, you might get one of those crashes if we're dealing with inheritance. Okay, so that's another important piece of that there. Cool. Yeah, the other stuff about final and abstract and things you can cover, equals you can cover in the next course. Not too concerned about that. Yeah, is instance of, that's all stuff you can do later on the next class. No big deal here. Okay, cool. So I think we've covered the basics of inheritance. Again, talk more about classes, more about testing, which should get you in a good shape for writing your plain class. Again, all you need is the class and the tests. If you want to put something in a main method, go for it. Totally up to you. I'm not going to look at it. I'll just ignore it. I'm going to say, do you have the class with the right attributes and the right methods? Do they do the right things? And then do you have unit tests to make sure that all of those lines of code are run eventually? Right, that idea with 100% code coverage is that every if block is run, every else block is run, whatever, if every one of them, right? If you have a bunch of them, that every line is going to be ran during our tests to make sure we know what it's supposed to do. Did it do what it's supposed to do? Because the computer is better at checking that than us. Okay? All right, so let me grab last semester's midterm here. I'm just going to turn my screen off for a second here because I don't want to screw anything up. Let's see. This was the summer. Quizzes. Midterm preview. All right, easy. Got it. So it had 18 questions. The first question is your re-acknowledgement of the academic integrity policy for the course. Understanding it's open book, open notes, open internet, but you cannot work with other people on it. And everything you submit, I'm assuming is yours unless cited otherwise. Right? Same rules apply. If you find something online because I wrote a question that you could Google, that's my bad if you cite your source. Right? That does not mean you can go out to Chegg, post it, and say, oh, hey, look, someone put the answer on Chegg. I really thought that was obvious a couple semesters ago. I've learned otherwise. Right? Any use of Chegg for anything, if you cite Chegg, you'll fail. Right? You are not allowed on that site for this course because they are awful, and thankfully they're getting sued by Pearson, who's also awful for their price gouging, but hopefully they both lose a bunch of money in the process. So, open book, open notes, open internet, right? Use your resources. Programmers get paid lots of money, and no one ever says, don't look anything up. Right? That'd be stupid, right? So I expect the same for you. Know where to go find your information. Right? It's coming from the textbook, it's coming from things I said, coming from things we practiced. It's really easy to get stuck in a rabbit hole on like Stack Overflow, because they ask all sorts of weird stuff, and like, yeah, it's kind of related, it's kind of not related. So just like, it's all in the book and stuff we've done. Right? No surprises, hopefully. And then there's 15 questions, quiz style questions. I used to write my own questions, and then turns out that was a lot of work, to be honest. And then I'd have to grade them all, and then people would be sad if I wasn't grading them on time. So I moved over to using the test bank, which better lines up with the book anyway. So it's still your incentive to read the textbook so that you're getting my examples in class, you're getting the book's examples from reading it, and then you're practicing it, right? So having done it a bunch of different ways hopefully helps cement the concept. So I've at least talked myself into it's okay to use test bank questions. I used to hate them, but that's okay. So 15 quiz style questions, then 3 long answer questions. We'll actually write some code here. So like this one, write a loop that asks the user to enter a list of classes they need to take and writes them 1 class per line to a file. So we haven't done files yet. This is out of order, bummer. But it'll deal with loops. A question on loops. So forget the file bit of it here because we haven't covered it. We'll get to that a couple more weeks. Was that next week? No, I don't remember. Let's see, because I don't think we've gotten to files yet. It's inheritance, and then I really should remember, folks. I'm sorry. It's not at the top of my head. Let's see what's next week. Yeah, arrays and a collection. So we won't do the way our midterm files is after. It used to be earlier in the other textbook. I don't know why. So it'll be on loops. A question on loops, right? And it's something pretty basic, like ask them to do a loop until something. All right, a question on methods. Here's a method plus minus multiply that requires 4 integer arguments. add the first two together, subtract the third, multiply by the fourth, return the result of that. These are not long. Like I had this in mind that we would just sit and do it in the 4-hour block, but then that just felt bad too, so they had more time on it. All right, and then the last one, write a class flower that have private attributes for name, color, smell, number of petals. Add get methods for the attributes. Add a method pick a petal, which reduces the number of petals the flower has, but does not allow the number of petals to go below 0. That's it for the midterm. Like it's meant to be low stakes, not anything crazy different. Your projects are harder than this, but this is the exam portion, right, of things. So sit down, write the code to do the thing. So it'll ask you to write a class with something. Here, that's it. There's no tests, no unit tests involved like your project, right? The project is going one step further. And this is a bit more basic than that project even, right? A relatively simple class, okay? Write a method, something basic. Write a loop. So hopefully a lot of the pressure's off and no one's scared of the midterm. I know exams suck, but I get funny looks if I don't have them on my syllabuses. So, and mostly it's free points if you're doing well, right? If you're doing well, then you get a bunch of points for doing it. So that's a good bonus there too. So I'll print this as a PDF for you here. I think that ought to work. Save the PDF. No, that does not work. That shows just that screen. Okay, I highlight it all and print. Does that do it? Yes, that was the trick. I have to highlight it all. Now you can see all the questions. So the quiz style questions, again, not even all that important. I'm going to use the test bank style questions rather than writing my own, and then long answer style questions. So let's save this as the practice. This is, oh my goodness, sure. I'll just call it practice midterm. And I'll go throw this out here in D2L. Midterm, sure. It can have its own section here. And then we'll grab the practice midterm, throw that in here. All right, got the practice midterm out in D2L for you folks to look at. We'll go over those couple short answer style questions. Forget the files. Here, let me put a little note. You can ignore the part of the loop question about files. Okay, hopefully that makes sense. Won't be any surprises there. So question on loops, question on methods, question on classes. And those are the long answer style questions. So pretty straightforward. And then 15 quiz style questions. But yeah, I should put that in here too. You'll have, oh, it did start. You'll have, I can't type there all week starting. So that puts us at the 26th, right? 10/26, 6 p.m. until the 2nd, 11/2, 6 p.m. Complete the midterm. So given it's open book, open notes, and we have no time limit, I don't have plans to come in person. If you'd like to use the computers here, go for it. I can make sure the lab is open. If you want me to come and sit and watch you, sure. Just let me know. I'll come and sit and watch you. Other than that, you can do it from home. I don't care. I'm going to trust you folks to not work together. Please don't do WhatsApp groups or groups on Discord and things and chat together about it, because this is your individual assessment here, and it's not hard. Right? If this is hard and we've gotten this far, something else is wrong at this point, okay? Is that fair? So that'll be out there. So we'll go over it again next week. We've got the rest of tonight to practice or work on project 3 and get that done. Again, it's worth more points than the previous one, so let's make sure we get them all in. I love when people get 100% on projects. It makes me happy. Like, honestly, I tell my wife, like, when people fail projects, I just get sad. I'm like, why? And then people are like, oh, I didn't know what was going on. And like, why didn't you tell me? And they're like, oh, I don't know. So yeah, ask me if you're stuck on something, please. That's why I'm here. Cool. I think that's all we got. Awesome. So we'll end this here. If you folks online have any questions, I'll be around on Discord, call, text, email, and we can go from there.